Hey everyone! In 2016, India-based studio Notting Head Games set out to develop Raji, an ancient epic, an action-adventure game set within a fantastical recreation of medieval India, to boldly represent the country on the world stage of game development. Head to the Unreal Engine feed to find out how the Unreal Dev Grant recipients turn their hard-bound dream into a reality. Want to amplify your project's sound design, add interactive videos, or are you looking to get started with animation basics? A new batch of courses on these topics and more is now available on the Unreal Online Learning portal. Visit the portal for a complete list of these free online courses and begin a new class today. Well known for their Zelda-themed animated short Majora's Mask Terrible Fate, Ember Lab's talented team of artists have pivoted into indie dev with their highly anticipated game, Kena: Bridge of Spirits. Set to release in 2021, Kena is a narratively driven action-adventure game that infuses the studio's rich art with exploration, puzzles, and combat. Discover the secrets behind Ember Lab's creative vision on the Unreal Engine feed. BMW now has a single real-time platform connecting departments throughout its business, from design to manufacturing to sales. The results are faster design iterations, better informed planning decisions, and a more compelling sales pitch. Check out our spotlight on BMW to see how Unreal Engine is helping their ROI. Interested in trying the newest features coming to Unreal Engine? Start exploring them in Unreal Engine 426 Preview 4, now available for download on the Epic Games Launcher and GitHub. To see the full list of changes and provide any feedback on the previews, jump into the Unreal Engine Preview forum thread. Time to highlight our top weekly Karma earners, many thanks to Every Nun, Clockwork Ocean, Evil Cleric, Detach789, Mama Marcis, Shadow River, Rev Overdrive, Crisp Clover, Georgie Kostava, and Maki Girl. Thank you all so very much. Up first this week, we're featuring Stylized Station, a channel dedicated to tutorials and assets that demonstrate how to create 3D textures and world building. Watch an array of videos from a variety of creators on building cozy homes and faraway sci-fi stations, stylized VFX, and more at stylizedstation.com. Avenge the death of your friends and family as a simple Chinese fisherman in a classic beat-em-up style in 9 Monkeys of Shaolin. Reminiscent of 70s kung fu movies, grab your trusty battle staff and download the action-packed title on Steam now. And our final spotlight this week lands on Anchar Studios' Tom Bentkowski. In his latest work, he makes the most of Quixel Megascans and Marketplace content to explore a realistic basement scene with UE4's virtual camera app. Explore more of Tom's experiments and lighting trials on his ArtStation page. Thanks for watching this week's News and Community Spotlight.
Hi everyone, and welcome to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I'm your host, Victor Broden, and today I have Jean-Michel Dignard, lead programmer.
Hello.
Lauren Delane, lead animation programmer.
Hi.
Marcus Wasmer, engineering director for graphics.
Hello.
As well as Simon Tourangeau, engineering director for the tools. Welcome to the stream. Today we're going to talk a little bit about what's contained in 426. And to start off, I would like Lauren to kick off with a slide deck.
Thank you, Victor. Yes, we have a few exciting features coming to 426, and I will talk about a few of these. The first one is the property access system. With this, you don't need to manually marshal your values from gameplane to your event graph and then wire those to your animation nodes. Instead, the animation nodes can pull the data that it needs automatically in a thread-safe way. This is using FastPath, so it's not hitting the Blueprint VM, and so it's done natively. This change also happens to improve the performance of FastPath. We have about 25% gains, and also improved its feature set by adding support for array access and nested structs. In this screenshot, you can see an example of pulling the velocity from the owning actor, so you can pull data from pretty much anywhere. On the UI side, this is what it looks like before and after. You can bind properties in a details panel, and so it reduces the clutter in your animation graph. you can see you don't have these extra properties and wires hanging off your animation nodes. But I have to give a shout out to Thomas Sakanen, who's been working really hard on this feature. Next up, we're going to talk about improvements to Control Rig. We have a lot of exciting work that's been done there. I would like to also give a shout out to that team who's been working really hard on Control Rig and doing great work. We have Helge Matti, Jeremiah Grant, Jack Kai, and Sarah Schwartzman. The first exciting news is Control Rig is coming out of experimental finally and is now in beta. So that means we now have a stable API. The first new feature is the Control Rig component. This allows you to run Control Rig outside of the animation system. So you can drive things in a data-driven approach. This is the case with skeletal meshes, where you can map to bones automatically. This is what you see on the screenshot on the left. But you can also do that with static meshes, instant static meshes, and any component. So you could build an entire modular car out of static mesh pieces, for example, and have it all driven by Control Rig. So you can make all the doors, window opens, wheels turn, and so on. But you can also drive things programmatically. So you can pull the data yourself and then drive any actor or object property from it. So you could drive cameras, lights, whatever you want. The next feature is the addition of looping and branching. This really helps manage rig complexity. You can create a collection of items and then loop over them. So for example, you can abstract the functionality of a squid tentacle. So you would author this behavior of the tentacle just once and then apply it to a collection of tentacles. This really reduces the number of nodes that you need in your rig, which in turn improves the performance and then just the management of your rig. The next exciting feature is rig inversion. The default Control Rig graph computes a pose from animation inputs. The inversion graph allows you to go the other way. So from a pose, you compute the animation inputs. This enables a bake to Control Rig feature in Sequencer that we'll talk about in a little bit. But essentially, that allows you to take a baked animation and then remap it to curves that animate a complex rig and not just a simple FK rig. The next feature we're excited to release is our new full body IK solver. This is coming out as an experimental feature, so we don't yet recommend it for production use. You can access the solver in Control Rig as a rig unit node, and then you can customize constraints, solver properties, everything that you would expect. Shout out to Lina Halper and Jeremiah Grant, who have been working very hard on that one. We've already seen a lot of people use it in the community since the first preview 1 of 4.26 came out. And it's really exciting to see the things that's been done so far. Here are some examples that we've put together to showcase those systems. Jeremiah Grant rebuilt the slope warping functionality from Paragon entirely in Control Rig, and then used the new full body IK solver to solve the final IK pass at the end. And here's the octopus. So that's an example, internal example we put together. So that's why I was mentioning tentacles earlier. This is showing the new looping and branching functionality from Control Rig, as well as the full body IK solver. You can see it on the legs there, but it's also on the tentacles at the same time. Next, we're going to talk about animating in Engine. We have a lot of exciting features there as well. The first one is a new option to edit animations. When you click on that, it creates automatically a procedural rig. It's a FK control rig, which basically adds a control for every bone that you have. It can then generate an override or additive track and has simple filtering to reduce the number of keys that you're dealing with. It's in Sequencer. You can use all the filtering functionality that Sequencer has to reduce those keys even further. But the next version of that is to bake to Control Rig functionality. So that is leveraging the inversion graph that I was mentioning earlier. So given a baked animation, it will create a new track in Sequencer with animation curves that will drive the Control Rig that you've created. So at that point, you're able to animate with high-level controls such as IK and look at targets instead of just simple AFK ones. And last but not least, and you'll see a pattern there, we now also support importing control data from FBX into Sequencer. That means if you have matching rigs between Maya and in Unreal, you can import the control curves instead of a baked down animation. There's a simple remapping panel, so in the case that your controls don't exactly match up, you can make sure that they do. But this is really powerful because it transfers the authoring process from the DDC entirely into Unreal. And then next, we have some updates on Sequencer. I would also like to give a shout out to Michael Ziraki. He's made some improvements to root motion that we're going to talk about here, but he also worked on those previous animating and engine features with the control rig team. So in the event that you have two animations with root motion and the root bone is not located in the same space, you can eliminate now that sliding that would happen when blending those animations. This works by picking the bone to blend to and from. You can also preview the skeletons and the root motion trails of the animations you're trying to blend. The next feature is a big one. It's a major refactor of the Sequencer runtime to be both more performance and memory efficient. Based on real-world metrics from Fortnite events and concerts, as well as UMG animations, the runtime was redesigned to allow for much better scalability and to allow for evaluation to occur on the task graph. In this example, we're animating several hundred actors, and we've made it about 3 times faster. The important takeaway is that this is totally transparent to the end user. This refactor is happening under the hood. It's also foundation, so there's a lot more optimizations that are coming. And this also helps the performance of UMG animations tremendously. So it's not just a sequencer-only optimization. Here I'd like to give a shout out to Andrew Rodham and Ludovic Chabant, who worked really hard on this one. And to wrap up, some improvements to the high-quality media export tool. Actors on layers can now be exported to separate layers or to a matte or alpha channel. This can be exported as separate layers in an EXR file, so you can leverage these layers for post-processing. Additionally, we've added the ability to render out post-processing materials such as motion vectors, world depth, or ambient occlusion. So if you want to do more advanced type of post-processing, you can leverage those. You can see on the screenshots, the plant was a separate actor on a separate layer in the level. It's rendered as a separate layer with its own mask in an alpha channel. And then you can do color correction in post-processing only on the plants after the fact. There are a lot more updates listed on the side of this slide. I won't go over them all for the sake of time, but if something catches your eye, you can make sure to hit our release notes or communication channels. For this, I'd like to give a shout out to Matt Hoffman, who has been working hard on those, and the rest of the Sequencer team. I think that wraps it up for the animation updates.
Thank you, Lauren. All right, with that wrapped up, let's move over to Jean-Michel.
Yeah, sure. Share my screen.
All right,
Okay.
it's all good to go.
Yep. So I'll be presenting the new features and improvements in 4.26 for Datasmith, Visual Data Prep, Variant Manager, USD, and Alembic. So we'll start with Datasmith. So we have 2 new exporters in 4.26. One is for Rhino and one is for Navisworks. So if you're working with those applications and you need to get your scene data into Unreal, you'll have that new option. We also worked on our 3ds Max exporter. We've improved our support for Corona materials. So if you're using the Corona renderer, you'll be able to convert those materials and load them in Unreal. Also for Datasmith, we have 2 new experimental features. One is the new runtime importer, and the other is a connection between external applications and Unreal. And I'll show you a little video of what that can look like. So in this case, to the right, what you see is an Unreal application that's running. And to the left, we have two instances of rivets with different models. And what we'll do is that we'll connect the Rivet applications to Unreal to be able to view changes that you're doing live in Rivet into Unreal.
Jean-Michel, sorry for interrupting.
Yeah.
Would you mind restarting the stream? We're seeing the low bit rate, like I mentioned earlier.
Okay, sure. Let me pause that.
Just a second, folks.
Is it looking better?
It's still the same, unfortunately. This is how it happens when it's live, folks. It works great right before when you go live, and then immediately to go live, it's anything that can fail will. It's okay. We can't really see the interface of Revit, but we can pretty much make out what's happening in the Unreal application.
Yeah, okay, well, I'll narrate over it. So basically what we did is that we pushed one of the house model from Revit 4 times into Unreal to lay it out like an housing project. And then what we'll do is that we'll make modifications in Revit. In this case, we'll change the phase. So we'll move for building into the furnishing phase, and we'll press refresh in Revit. And you'll see the furnishing starting to appear in Unreal as we're receiving that data. New actors are getting spawned, new meshes are getting created, materials are being applied, all that. And then we'll go in our other file and we'll change our phase again to the landscaping phase. So this phase in Revit adds trees and other types of landscaping, and you'll see them appear in Unreal. So in that way, you'll be able to use Unreal as a viewer to see what your project could look like. Again, this is experimental. Yeah, sorry. Let's continue to the next slide. Okay, and then we're moving to Visual Data Prep. In 4.26, Visual Data Prep is now production ready. The improvements that we've done to it is that you can now filter and operate on actor components in your recipe. We've also added new filters and new operators. We've done UX improvements, and we've added new modeling tools operators. So from a data prep recipe, you will be able to simplify meshes, bake transforms into your vertices, remesh your meshes, weld edges, and things like that. Up next is the variant manager. So new for 4.26 is what we call variant dependencies. So what this allows you to do is when you activate a variant, it will also trigger other variants that are its dependencies. So what you'll create with that is either packages or configurations. So like in this case, for this bike, we have a default package, a sport package, and what we call the flash package. So each of these are variants and they have dependencies. So for example, the default package will change the paint to blue. It would change the logo to white. It will change the rims to black. So think of it like if you're buying a new car and you're buying a package, it comes with a list of options. So we can do those kinds of setups now in Unreal. And you're seeing the result on the bike. That's it for the variants. And now for USD. New in 4.26, we've made improvements to what we call the USD stage. The USD stage is when you work directly with USD files in Unreal, so you have access to a USD stage editor to edit your USD data directly, so your layers, use different purposes, the trigger payloads, things like that. So in our USD stage workflow, we've added animation authoring. So basically what we did is we put USD into Sequencer. So if you're creating transform animations in Sequencer, they will be available in your USD data also. Right now, it's limited to actor transforms. We're hoping to to augment that to other types of animations in the future. We've also added support for USD lights, which was previously missing. We've added support for USD blend shapes, so for your facial animations. It's in Unreal, they're called morph targets. And we've also added support for normal maps for the USD preview surface materials. Also for USD, we also have an importer path. So if you want to take your USD assets, convert them into Unreal assets to use in your project, as you would with FBX or other file formats, you would use the USD importer for that. For 426, it got completely rewritten. The goal was to brought its feature set up to par with our USD stage. So doing that, we can now import static meshes, skeletal meshes, blend shapes, anim sequences, point instancers, materials, actors, camera, and lights from your USD data. And finally, for USD, we also have exporting capabilities. So if you have Unreal assets, you need to export them as USD. You can do that. We've augmented our feature set over there. So we can now export vertex colors for your meshes and your skeletal meshes. LODs, skeletal meshes is a new type of asset that you can export to USD from Unreal. It will come with blend shapes. You can also bake Unreal materials to USD. So you'll get one texture per channel and you will have a USD preview surface material created for you. And we also export material assignments. So the materials that you've assigned to your meshes and your actors. Also for USD, we now support the USD-Z file extension. We've added support for USD on macOS. So we now have all of our editors support USD, so Windows, Linux, and Mac. And we've upgraded the USD SDK, and it's now on Python 3. Finally, for Alembic, if you're using Alembic files to get animation into Unreal, we now have a process of streaming Alembic files directly in Unreal. So we have a component that would point to an Alembic file, and it would stream the Alembic animation directly into your level. It's very useful if you want a quick iteration time. You don't have to import all your Alembic data into Unreal every time you make changes to it. Also, the Alembic data that is streamed from the disk are uncompressed, so you get exactly the same result as you would in another application. And we've also added support for Alembic velocities. So it's mostly used for non-constant topologies. If you have animations like more around effects like splashes or things that morph over time, Alembic velocities will allow motion blur to work in Unreal. And that's it for me.
All right. So unfortunately, we didn't have full bitrate there, but I do believe that all the text was able to be viewed by everyone. All right. Next up is Simon.
Thank you, Victor.
We're just speed throughing this.
Okay, so I'm going to talk about a few features that should be very helpful for virtual production. First of all, a very useful feature that to control a live set is the remote control. When you're shooting on stage with a virtual camera or with an LED wall, you need to be able to make quick changes to your set. You might want to control lights, move or hide objects, move the sun, the clouds, or even run sequences. We've had the web remote control since 4.23, but you had to manually specify the full object paths, the property names that you wanted to control. And then to control it through the REST-like API, you needed to do some web programming every time you wanted to change the layout of your control application. So it worked, but it was somewhat painful. So for 4.26, you can now select the properties that you want to control directly from the editor. To use it, you have to enable the Remote Control API plugin. Then you create a Remote Control preset asset. And when you open that asset, you have visibility icons that appear next to the properties in the details panel. So you see it here toggling the location and rotation exposure. Once they're exposed, you can rename them to make them easier to find. You can also group them to make it easier to manage once you start exposing lots of properties. Once your properties are exposed, grouped, and named appropriately, you can start building your web interface. And that's pretty proud about what we've been able to do here. We've developed an extensible web application, so you don't need to do any web programming anymore. You can easily control the layout, add widgets, and assign the properties you previously exposed. And in this example, we're adding a joystick widget to control the Z value of the box's position, and it just works. It's much more efficient and easily customizable. We have many widgets like checkboxes, sliders, color wheels. Now, when moving that box, you notice that there's a bit of lag. You have to remember those are web requests, so it's not intended to be to replace a game controller or to do anything time critical. It's meant to tweak your set and prepare for the next shot, and it's doing this very well. In this example, we're playing around with the light color, something that often needs tweaking during virtual production shoots. It's going to prove very useful on the virtual production sets. You can then run this on your iPad or any device that you have, just connecting to the web server. Next, I'm going to talk about NDisplay. If you don't know already, NDisplays are a distributed rendering solution which came out in 4.22, I think. Makes it possible to use a cluster of computers and GPUs to render a scene to multiple screens while keeping them all synchronized. When you start having a complex NDisplay setup with multiple computers and multiple viewports, it can get very difficult to manage. With 4.26, we're rolling out the NDisplay config viewer, which makes it possible to visualize the configuration and understand the output mapping. As you see in this example, there's a lot of viewports, and they all need to be placed correctly so that the final output on the wall or your screens will look right. And a future version will provide the capability to configure your setup directly from the editor without having to manually edit your config. For now, it's visualize only. You can visualize properties and everything. Eventually, you'll be able to do it from there. For now, at least, you can visualize it and quickly identify any errors. You can also preview your viewports directly in the editor. So another thing that will greatly simplify debugging. Other important improvements that we've done, chaos is now deterministic across the cluster, so physical events are kept in sync. Cluster events are now sent in binary format to improve performance. We've seen some people abusing cluster events, so performance was degrading. We've added NVLink support for a dual GPU system. So when shooting with LED walls, you use most of the wall as a lighting source, so the resolution of what's not in the camera is not that important. For the parts that are in camera, you'll want high resolution. So usually you render outer frustum at low resolution and you composite on top an inner frustum. With NVLink support and dual GPU, you can have one GPU render the inner frustum at high resolution and transfer that render to another GPU who already rendered the outer frustum and then composite it together. It brings a significant performance boost for complex scenes. Another nice feature is the inter-process GPU texture sharing. It's available through NDisplay or as a standalone. You can find it in the texture share plugin. It makes it possible to efficiently send and receive GPU texture data of any kind, resolution, and format between Unreal Engine and other processes while bypassing the CPU. It supports synchronization mechanisms and thread barriers so that coherency is kept between shared applications. In this example, if you look at the bottom right, you'll see a very simple external app that renders a rotating cube. The texture on the cube is coming from the Unreal Engine editor's camera point of view. As I said, it sends and receives, so you could gather a texture from an external application, bring that to Unreal. And that's it. Up to Marcus.
Thank you, Simon. Are you ready, Marcus?
I'm getting ready. I was prepping for one of the physics questions in the chat. Let's see if we can...
Marcus actually has a slide deck for us this time.
I do have a slide deck for you. I sort of kind of prepared this time around.
Excited to see it.
Everyone else kind of guilted me into it with their awesome slide decks. All right, let's see here. Let's go back to the beginning. All right, is that good?
Looks good, yeah.
Wonderful. Okay, so definitely got some cool stuff to talk about today. I'm going to be an evangelist for the core team here to start with the new Zen loader. So we got next-gen consoles coming out soon, and hopefully everybody knows at this point that they have super fast SSDs in them. So we spent a lot of time working on load times to support those things. And now in 426, happy to note that the new Zen loader is finally in beta. It's stable. It's actually shipping in Fortnite now on I think PC just in the release that just dropped, and consoles in the last couple releases. So you've got nice improved load times, streaming times, and boot times. We're going to have docs coming, but to use this thing, you just have to pass -IO store there to UAT when you're packaging your game. Unfortunately, you do only get the loading benefits on a cooked game, not in the editor yet. But it is worth it. It can be up to 2 to 3 times faster, depending on your content. Your mileage may vary, but for Fortnite at least, Fortnite content, we got really, really good speed increases. So I really encourage everyone to try this out on your games if you're updating to 426 and shipping updates or have a game coming up soon. Let's see. More cool stuff from the virtual texturing guys. So one big change is we added an indirection for the virtual texture page table. So you can think of virtual texturing as more like it's kind of like an indirection for your texture lookups. So instead of directly looking up a texture, you're looking up into a little, we'll call it a page table as for where your texture data actually is, which lets you sparsely load the texture data that you actually need rather than, say, loading an entire 8K texture. You can load just little pieces of the 8K texture that you need for what you're currently looking at. And this saves a lot of memory and streaming bandwidth. But the size of the page table limits kind of the virtual size of the full texture size that you could possibly have. So this was a little bit limiting. The virtual size that we had before was something like a million texels by a million texels virtual texture, which sounds really big, and it is. That's about enough to cover, like a 1 by 1 kilometer square world or 2 by 2 kilometer square world at about 1 texel per millimeter. But by using another layer of indirection and virtualizing the page table itself, we've gotten that up now to 256 million texels by 256 million texel virtual texture size. And this is enough to actually to texture a really huge world of around 256 kilometers square at that 1 texel per millimeter fidelity. So really big news for people that are like, building really big worlds, or if you want to have even more fine-grained detail, it's pretty nice. And then also kind of related to the virtual texturing stuff, we've got the new virtual height field mesh coming in. And this is kind of a replacement for landscape rendering. Landscape rendering is great. It's pretty cheap and efficient, but you can run into issues where you just kind of can't get the detail that you want out of landscape rendering without spending a lot of performance and memory. So with the virtual height field mesh, it uses a runtime virtual texture to generate the height map detail that you want to render in the scene. And so often, the initial height field data will come from, your landscape that you authored, and then pull the height field from that, render that into this runtime virtual texture. But then also you can put more fine-grained detail of like tiling textures or really small detail into that runtime virtual texture. And then that gets rendered via a new GPU rendering path of small mesh patches that kind of align with the virtual texture tile size. And so this means they can be efficiently culled on the GPU, efficiently LOD'd with the level of detail that you need from a given camera view. And just overall, you get a nice performance quality and memory benefit from using the height field mesh. So it's kind of a triple threat. It is experimental in 426. We haven't used it in anger yet on all platforms, but I highly recommend checking it out if you're building large landscape worlds with your projects. And just quick, come on now, there we go. Quick example, you've got, this is what kind of a flat Fortnite kind of terrain would look like with just landscape, but with the virtual height field mesh, you can get a little more fine-grained detail in there without as much performance and memory spend as you would otherwise. So again, experimental, but definitely worth checking out in 426. And I think kudos to Jeremy Moore on Simon's team for that one. Other nice improvements, I've got some big changes to the sky, cloud, and environment lighting systems that we've put in place. You might have seen over the past couple of releases, we've been kind of slowly adding in features to sky lighting and cloud rendering and things because we really wanted to unify all these systems and kind of level them up for current generation and next generation games. So one of the nice things added in 426 is that the sky atmosphere model can now receive shadows from opaque meshes and from the new volumetric cloud systems. So you can see some examples here where you're just going to get naturally nice light shafts through the atmosphere from the opaque meshes. And if you're really zooming out and you can kind of do small planet rendering with the new atmosphere model and put some like giant superstructures onto your planet, you can see you can get planetary shadows out of it as well, which is pretty cool. Also, I apologize for the quality of this video. This is just like a blown up animated GIF I had to hand. So I didn't prepare as much as I probably could have. But skylights, if you're used to using them, will usually capture your scene on load. And so if you have a dynamic scene where the lighting is changing or objects are moving around in the scene, your skylighting can get pretty out of date with what's actually going on in your game. And there was ways around it before, like there was a blueprint node you could trigger that would recapture the skylighting, but it was pretty expensive and it would cause a hitch. So it's not something that you could actually run every frame like you would want to do in a very dynamic environment. But fortunately, we do now have a real-time skylight capture mode that works all on the GPU, and it captures volumetric clouds, opaque meshes, atmosphere, and really gives you consistent lighting out of your skylight across your scene. So definitely something to check out. It's not totally free. It is, it still costs something, but it's a hell of a lot cheaper than the old blueprint node used to be. So definitely worth trying. And then I think finally on the environment stuff, when you're trying to make a cohesive environment lighting set, you've got your directional lights, your skylight, your sky atmosphere model, your clouds, all that stuff. And it's really a pain to individually have those all over your scene outline and try to get them adjusted. So we added a single editor panel called the Environment Light Mixer, so that you can see all those things in one place and keep everything consistent. It just makes project management a lot easier for your environment lighting. Let's see what else we got. Okay, so hair is another thing that you've seen in the past couple of releases. I think the first experimental version was like 423 or 424 or something like that. Happy to announce that hair is now out of beta. There's been very significant improvements to performance and rendering quality and usability from the hair systems. Really happy with the results. If you guys haven't seen some of the results of the new strand-based hair rendering, you should really check it out. Like, I feel like we're really approaching film quality hair rendering at this point with the strand-based system. So huge props to the whole hair team. I've seen some pretty incredible renders out of this thing. One of the big features that's been lacking in previous releases, though, to make this useful for games and not just like pre-rendered cinematics, is the ability to try to run it on lower end platforms. So one of the features here is LOD generation, automatic LOD generation for the strand representation and to generate representation for cards and meshes. So, reducing the number of strands maybe for your next gen port of the game, going down to maybe cards for the same asset for your current gen, and then all the way down to kind of like your old school hair mesh helmet kind of thing for your mobile and maybe Switch ports, depending on where your budgets are. So it really gives you that end-to-end ability to use the hair system for any title. And then also there's a nice new groom editor or view here where you can just kind of see everything in one place, manage your materials, manage your physics simulation on the hair, kind of adjust strand lengths and some other tweakabilities to the hair. So definitely the place you want to be if you're editing the hair for your project. I feel like I'm talking a little bit fast. Hopefully not going too quick.
I think it's coming through all right.
All right. Another awesome thing that's been in the works for a while is GPU Lightmass, which happy to say we're now in beta. It's pretty stable, giving great results. So for anyone not familiar, like the original Lightmass for baking light maps is a CPU-based light map baker, and you can distribute it across like a CPU cluster with the Swarm system. But it does have some limitations, and those limitations are, first of all, like you can't see partial results. You kind of have to do, a full bake, and even on preview mode, they can take a while for big scenes. And also, your materials for Lightmass 1 are translated out of the editor into a simplified form, because Lightmass 1 is a Lightmass CPU is a separate program that has to ingest the data from the main editor and generate the lightmap data. GPU Lightmass, however, is completely integrated directly in the editor. So there's no material translation that has to happen. It can trace the full materials as they are. And because it's running in the editor and it works on tiles, it can do progressive real-time preview. So you can move things around, change your lights, and start seeing things change right away. It won't be full quality and won't be the whole scene, but you can watch it fill in, and you can start tweaking things if you don't like how it begins to look without waiting for a full bake turnaround. In the beta, we also added we added 2 modes, or added 1 mode. It had a mode before. So there's now full bake and bake what you see. So this is useful for, let's say you're on a virtual production set and you know about where your camera is going to be, and that's just where you're going to film. Like, you really don't care. If you have a huge scene, what the lighting looks like, a kilometer away somewhere. So you can use the bake what you see system to literally bake what you see. And this is a big performance increase for large scenes because it can just ignore a bunch of other data that it doesn't have to deal with. And that gives you faster iteration on the views that you happen to care about. For a full game where you can run around wherever, you're going to want to do a full bake. But it's a nice option to have. And again, so if you didn't know, the GPU Lightmass does require hardware ray tracing out of your GPU because it's based on our built-in path tracer. And so, yeah, you'll have to have ray tracing support on your card to try that out. But definitely worth a shot. I think I have nope, looks like I didn't upload the video. Oh well. I think we have some on the YouTube channel for some examples of that thing in action. All right. So other ray tracing updates. Hopefully people have noticed, but we did ship ray tracing in Fortnite. this was just a massive effort across the ray tracing and rendering teams. So, and the Fortnite teams. So big props to all those guys. It was really a big effort to get this in. The results are great. There's some places like this example where you've got the kind of glass, and it's like the perfect case where you can see very obviously the impact of ray tracing. Other cases, it's more of a subtle, it's kind of general image quality kind of feel where your shadows are grounded properly, your AO is correct, and reflections from the water and stuff are more correct. But aside from being cool for Fortnite, improvements to the engine were really critical to this process. Like going through the process of shipping it in a full game like Fortnite really made us buckle down and find the bottlenecks where we can improve CPU performance improvements by a lot. So like better buffer allocations and heat management, faster dynamic path for ray tracing because Fortnite is largely dynamic, better ray tracing, PSO handling. All that stuff really should mean that it's going to be much, much easier for you guys to add ray tracing to your games in budgets that make sense. Definitely way more than you would have seen in 425. Similarly to CPU, a lot of good GPU performance improvements were made with better WPO handling, a nice spatial acceleration structure for lighting sampling, more culling options for objects behind the camera, and a lot more. And last but not least, increased stability. So whenever you deploy a technology like this at scale, you're just going to find a lot more issues than you would in isolated testing. And we really found that to be true for Fortnite. And the stability of the system is greatly increased. There were a couple of pretty gnarly race conditions that they got tracked down that are really going to make a big difference for DX12 and for ray tracing. So give it a try. It's going to be awesome. Another nice rendering feature. This is one that's been in the works for a while, but anisotropy is now finally production ready. So before we had anisotropy support in the engine, the material model really wasn't able to correctly represent materials where your specular highlight needed to have kind of an oriented shape. The best example is like brushed metals. You got some aluminum with some scratches in it, and you kind of expect the spec highlight to follow those scratches. It's pretty hard to get that look before, but now with anisotropic material support, it's much, much easier to do that. It's exposed its default on PC and next gen, and there's no perf cost when it's unused due to how it's implemented. The cost of the anisotropy should scale pretty much linearly with the number of pixels that are using anisotropy that are being rendered on screen. The one big caveat here is it does not support area lights. That's an area for future research for us. Another really exciting thing is updates to TAA upsampling. So we've got a new experimental TAA upsampling algorithm that's available in 426. This is one it's designed for next gen, where we've got a little bit more budget that we can spend on the quality of the upsample and a few more tricks that we can run in the shaders. So we've got some pretty promising early results. It gets much better quality at lower screen percentages than the original TAU. However, we don't consider it production ready. It still needs a lot of testing on more types of content. So actually, we'd appreciate it if you give it a whirl and send us some feedback on how it's doing on your particular type of content, so that we can fix any issues that might come up with it. And then here on the slide, I have the instructions on how to turn it on that are going to be they're going to be in the release notes as well. So you don't actually have to come find this slide, but definitely some exciting research by Guillaume Abadie that's going on here. We got some cool stuff from Niagara too. This is one of my favorite ones, which is the particle reader or particle attribute reader. So with this module, emitters can sample other emitters' particles, which means you can look at other emitters' stuff, reason about how to do spawning out of your emitter from what's going on somewhere else, copy attributes from one to another to do like cool dissolves or other things. This operates on the GPU, which means it's fast, and it enables like lead-follower relationships. So using this, the Niagara team created some generalized constraint functions, and you can use these to do things like the chains that you see below, where each little chain link is like a Niagara particle, and you can see those things following each other around. So really, the sky's kind of the limit here with this sort of functionality. It really opens up a whole new toolbox for people making Niagara emitters. There's also a cool new built-in Niagara profiler. This integrates with the existing stat system. It gives you live emitter profiling of modules for CPU and overall script cross for GPU emitters. And it does work on emitter and system scripts. So this is kind of the first step on our road to providing Niagara profiles. There's a lot more planned here, all the way up to full integration with Unreal Insights. But for a first step, this is really helpful for starting to profile your Niagara systems. Other nice things, the Cascade to Niagara converter is a plugin that's now available in 4.26. It's not perfect, and some content will need to be fixed up manually after the fact. But things that it couldn't convert should show up as fairly clear errors in the process or in the Niagara modules. Not all Cascade functionality has an exact one-to-one correspondent on the Niagara side. However, if you've got a ton of Cascade objects and you want to get started with Niagara, this is really handy. It's something that we're continuing to work on, and we're expecting to add more and more Cascade modules that can be converted properly as time goes on. Let's see what else. Oh yeah, this is one of my favorite ones. The component renderer, which is experimental. So this allows you to spawn any kind of component from Niagara emitters. There were some unfortunate incidents when our tech artists first got a hold of this, so please try not to make your computers explode by spawning like 5 million lights and your most expensive meshes out of your particle emitters, but it can be really fun to play around with. It does allow, like, one of the first things that people wanted was high quality particle lights out of Niagara. So this now uses the component renderer to spawn true point light components out of Niagara. And again, it's really easy to go overboard with this, but it's really handy when you need it, for your cinematics or used sparingly in gameplay. And kind of continuing on with the idea of Niagara being like a fully integrated FX system, not just particles, you can now play audio much more easily from your sim. There's just like a play audio node that can do fire and forget stuff or persistent type audio. Really handy when you need to like line up audio and lighting with your emitter all in one place, rather than having to try to coordinate all that through Blueprint or something. And this time around, mobile rendering actually gets some exciting updates, which is not something that happens every release. So we actually have the normal desktop deferred renderer and the desktop forward renderer, the VR renderer, both available on mobile in some form. We consider these beta on iOS and experimental on Android, just because on Android there's such a wide variety of phones and hardware types that not all of the Shader Model 5 features that are really required to run those renderers are consistently available across all Android phones. But still, if you're targeting like a high-end mobile game, having these renderers available is really cool to get a consistent look or a higher-end look. And here you can see our Infiltrator demo running on an iPad Pro. In addition to just literally running the desktop renderers on mobile, the mobile render itself has gotten some upgrades as well. So Reflection capture compression, for one, should make your statically lit mobile games a good chunk smaller, depending on how many reflection captures you have. GTAO is our new AO algorithm available on desktop. And it's now available in an experimental form on the mobile render without having to use the desktop renderers. Dynamic spotlight shadows are also now experimental on mobile. We're starting to kick the tires on those. Still working on some performance and whatnot and compatibility, but definitely a nice upgrade for the mobile renderer. And another cool one is the pixel projected reflection. So this is a way to get something that's kind of like SSR on PC into your mobile games, which is a really nice visual improvement. So definitely kudos to the mobile team for knocking that stuff out this time on 426. And I think that is the end of my prepared slide deck here. So let me just go.
Thanks a bunch, Marcus. All right. If y'all got some time left, we can move over to some questions. We have received plenty from chat. Lots to talk about.
Surely not.
To start off, I'd like to take a couple of questions that we received on the forums. And with that note, I want to make sure that if you are curious about some of the features that are released in 426 that we aren't mentioning here today, make sure you take a look at the preview release notes that we have on the forums. Let's go ahead and Sam can possibly paste that in chat for us so you can have a quick and handy link. Moving on to questions. Does landmass and the water system function with world composition?
I'm going to let Simon take that one.
I think he's working on the unmute right there. Yep.
Yeah, I was sending messages. Missed the question. Can you repeat again?
Does landmass and the water system function with world composition?
That's a good question. I would assume so, but we're not really working on the world composition because we're focusing on UE5 and our new systems for world partition instead. So world composition will be coming to an end when we get to UE5. I don't know if we've validated the water on world composition. I can find that out.
We can follow up with that on the forum announcement thread afterwards. Is the goal of GPU lightmass to eventually reach feature parity with CPU lightmass?
The short answer is yes. Yes, that's the case. We expect GPU lightmass to actually be a superset of the lightmass 1 functionality because it being integrated into the editor, it should be able to support more material types and things than CPU lightmass.
Is Apex Destructible deprecated in 426? And there's a follow-up question. Are older projects with destructible mesh will not open?
Apex, as far as I'm aware, has actually been deprecated since somewhere around 420. And with Chaos, it doesn't function. Your map should still, your project should open, but I don't think that auto converts to Chaos Destruction. That might be worth confirming maybe on the forum or a support request, though. I'm 95% sure of that answer.
Let's see. So how much of these things, such as virtual production, are available in current 426 Preview 4? Are there items shown that have yet to appear in the beta versions?
No, all is there.
Yeah,
cool.
I don't think we're planning on any major development from previews to release. Should just be bug fixes by now.
There was a little bit of a wait for the water systems there that came in Preview 3, but they're in now. So here's a question for you, Marcus. Will that loading increase end up helping load uncooked content at some point? We use high-speed NVMe drives and would love to be able to take advantage.
that loader in particular is not going to help uncooked performance. Just kind of the way that it speeds things up. However, we do have a lot of work in progress for future versions of the engine to improve loading in general, like loading in the editor and other places where you might have uncooked data.
Will there be any more advancements to the volumetric clouds?
Probably not major advancements, although there are a few more minor artifacts and just like a few tweaks and slight improvements that are happening right now that are going to miss 426. So yeah, there'll be a small number of improvements in 427 to rendering quality, but I don't think any more major features.
Does or will the Zen loader work on mobile platforms?
Good question. So theoretically, it does. Yes. Well, not theoretically. I believe we have shipped it on Android on Fortnite. So yes, we did ship it on Android.
Will we get a vehicle physics SDK?
Yes. Chaos vehicles will be a thing. I think there's some form of them in 426, in fact.
Is the real-time Skylight production ready or still in development?
Again, 95% sure that it is production ready. I think we're using that in more recent Fortnite builds, like right now.
Is it possible to create an individual cloud in the sky with custom parameters?
I mean, you should be able to create a single cloud. Like, if you look at the volumetric cloud documentation, is probably the best place to go for that. I'm not intimately familiar with using it like Ryan is.
Ryan, are you there? He's not watching the stream. He's way too busy for this. Let's see. Can the GPU lightmass be shared using swarm agents, just like CPU lightmass? I haven't been able to set that up.
It cannot. That's one of the reasons why GPU lightmass is beta and not production ready, because we don't have a distribution mechanism for it yet, and we do think that's important to try to do before we call it production ready.
Will there be AMD ray tracing support?
Yes, we don't support vendor-specific ray tracing APIs. We support DirectX, DXRT. So when AMD has a card that implements DXRT, it should work out of the box. Like, we very explicitly did not do vendor-specific APIs for that.
Will you be implementing DLSS for ray tracing?
So we did ship Fortnite with DLSS recently. I think you have to talk to NVIDIA to see about getting DLSS for your project, though. I think that's like a individual conversation they're having with developers.
Yes, and if you're interested in that, we did do a live stream a couple of weeks back with Richard Cowgill, where we explicitly talked about the DLSS features as well as their global illumination solutions. See if we can get a link to that in chat as well from Sam. Let's see. Did you fix the volumetric fog with ray tracing shadows issue?
I don't know. I would hope so, but I don't know the specific bug we're talking about to confirm.
Quadfodder here had a question. Could you touch on the latest updates for automotive HMI features? Don't think we have anyone from the enterprise team here, so if any of you are watching and you want to go ahead and answer that question, feel free to drop those answers in the forum announcement post. Lord Ionacho asked, as far as ray tracing, is there a way I can set my game to adjust RTX mode without having to create another packaged build? If yes, could this also apply to changing shader models, for example, switching from DX12 to Vulkan?
You should be able to support like both DX11 and DXR ray tracing with a single package build. Fortnite does this. In theory, you could also do Vulkan as well. I think you just have to go into the project settings, and there's like a supported RHIs option with a bunch of checkboxes of like which RHIs you would like to cook shaders for when it's packaging the build. And then once those are all there, you can use like runtime command line parameters to change them. I think like -dx11, if you pass it on, will force dx11, -dx12 will force dx12, so on and so forth.
Delirium and Sovereign Dev asked, can the component renderer be used to spawn decals?
It should be able to do that, although I haven't seen anyone directly test that, but it should be able to spawn any type of regular component. It may not be efficient to do, though.
Zakarmakun asked, is it possible to create shading models from plugins in 426?
No, it is not possible to create shading models as plugins.
Motorstep asked, should we expect further fixes and improvement for chaos physics before 426 release?
Yes, the physics team is closely monitoring all the feedback that you guys have been giving us. And I think Preview 3 and Preview 4 both had some pretty significant changes to the defaults to increase stability of the stability of the solver out of the box, and there's a lot of performance improvements on the way as well. So keep the feedback coming. We're definitely watching, and I appreciate all the feedback from the use cases that you guys are bringing up.
So let's see if I can understand this question correctly. Jimmy Animal asked, importing smoke simulations, VDBs, I assume. Is this the right way to go in the project? Is it supported by UE4?
Sounds like a Datasmith one. I don't know if we support importing VDBs.
Not that I'm aware of. I don't think we have an import path for that.
Yeah, smoke simulations. I mean, if you're a Houdini user, I think the Houdini plugin to go to Niagara might be a good path for smoke simulations. Or some sort of Alembic type of export might be a good option as well.
That's a fly. Camber XP asked, MSA currently has some issues on PSVR. Any chance to be fixed in 426? I think we might have to direct that to the XR team.
Yeah, I'm not aware of any specific changes to MSAA on PSVR, but that doesn't mean there aren't any.
See, we have some more questions come in here. Just give me a second to go through. Is it possible to use Control Rig in a UGC package copy of Unreal Editor for my mod kit of my game?
It's a good question. I've not tried that. If it's shipping the editor as part of it, I would assume so. Although I've not tried it, so best is to check and then get back to you on the forums.
And if anyone's listening, you're wondering what UGC is all about, go ahead and check out the live stream we did with Chance Ivy a couple of months back, where he walks over how to use the plugin that he built, which allows you to build a simple version of a mod editor for Unreal Engine. It's good stuff. The Digital Cowboy asked, any improvements to ray tracing in large landscapes with displacement?
Not specifically for that, but just in general, I would expect WPO performance and landscape performance to be improved in 426, just as a result of other general improvements. But I don't think a specific effort was made on that use case.
Mac Eisen asked, will model UDIMs ever be supported for materials?
That's a good question. So UDIMs are supported on virtual textures, I believe. You should be able to apply those in your material to a model that you want. Or if model UDIM is a specific thing, maybe I'm not familiar with that terminology.
Zakarmakun asked another question. Is it possible to write a U-texture render target 2D through RDG?
Yeah, that should be possible. I don't see why not.
All right.
You might have to like dig into the UText. You probably have to dig into the render target, the U render target 2D, and get the actual FRHI texture thingy out of there to pass to the RDG. But if you're writing RDG code, you're probably familiar with that level of the system anyway.
Are y'all good to take a couple more of the remaining questions that we received?
Yep.
Sure.
All right, cool. Is recapturing the skylight in each frame, question mark. Can we set up the recapturing interval for doing it like 1 per second?
Good question. I think the behavior as implemented there is every frame. I don't know if there's a built-in way to do it less frequently. But I also don't see that it would be terribly difficult to mod that code to do it if you wanted to. But yeah, out of the box, I don't think it has that control.
See, and there was a question from Asander. How do you enable the mobile deferred renderer on Android?
So that is in the preview release notes, I believe, but there's a couple of project settings and a CVAR too you have to switch. But yeah, if you look on the forum for the preview notes, I think it's in there.
Let's see. We're definitely receiving some new questions here since we're in the Q&A aspect. How about PSO cache on Mac OS? Does it work or will it be deprecated in the future?
It does work, and we don't have any plans to deprecate it. At least until we come up with something better that also removes hitches.
And I am seeing a couple of questions coming in regarding UE5. We will not be covering any of those questions here today, but stay tuned for next year. There's a question in regards to HTML5, and I can go ahead and answer that. The HTML5 plugin is currently no longer shipping natively with Unreal Engine. You can find it on GitHub. You are available to do pull requests there, just like normally do. And we're hoping that the community will kick that off, and we're excited to see if there's a big initiative there. Do you have an ETA on GPU Lightmass being production ready?
I do not. It's probably going to be a while before we really consider it like fully production ready in a like a big AAA game sense. As far as like the quality of it, because of that distribution mechanism, like I mentioned, that's kind of a hard problem to solve well. But quality-wise, we're pretty happy with it. I think if you had, if you're able to use it as it is now and bake the levels that you have in a reasonable period of time on your GPU, then you could absolutely just go ahead and use it. It's more the case of really big games not having a mechanism to keep the overall bake times for the entire game to a reasonable amount. That's keeping us back from production ready.
DJ Solid asked a question. Is Epic planning on making a complete animation creation tool / program within Unreal Engine at some point?
Well, we're definitely taking steps in that direction, as you can see from our 425 and 426 updates. So the answer is yes.
Alex Mendez asked, are you planning to update the engine's OpenCV lens distortion plugin to do optimized distortion accordingly to distortion coefficients?
Unless Simon knows of any, I'm not aware of any plans to update the OpenCV distortion thing.
I'm not aware of any either.
Rom895 asked, will GPU Lightmass support for stationary skylights and adjustments to indirect lighting intensity for materials and lights?
GPU Lightmass in that sense is only meant to be at feature parity with CPU Lightmass. So I don't think there's any extra controls there being planned that don't already exist.
I'm seeing some questions come in regards to the water system. I will highly suggest you go watch the live stream we did with Ryan Brooks. He walks through the new water system very in much detail. And so if you have any questions in regards to that, better to go watch the stream. He's the master.
Yeah, definitely agree.
Let's see. Any improvements to AI navigation and avoidance? We need to get Mieszko on the streamer sometime. Been working on that.
Yeah, Mieszko, Maxime, or someone. Yeah, unfortunately, I don't keep up with AI guys.
Pirate Tony asked, similar data streaming question. PSO cache still works without changes or will be replaced in future releases? And then and do you have a plan to do a stream about PSO? That would be pretty cool.
Sorry, what was the last part?
I was trying to phrase it in a way that it's a question. I think it's supposed to be PSO cache still works without changes, or will it be replaced in future releases? ?
Yeah, it's continued to work without changes. I mean, it's going to largely remain the same of you needing to do a collection pass and then preload the cache files. So there have been some improvements made in the last couple of releases to be able to make sets of PSO caches, so you can kind of choose what you're preloading if you can record them in separate sets. But the basic functionality is going to remain the same. In the long term, we have ambitions to be able to run the engine without the PSO cache, but that's really going to require a lot of infrastructure so that we can determine upfront a reasonable amount of PSOs that your game is going to actually use and be able to create them asynchronously, et cetera. So it'll be quite a while, I think, before the PSO cache has no place in the engine.
Odsta asked, will the skylight changes for global illumination address the multi-bounce issue where light is bounced off objects underground, like light probes?
No, I don't think so.
And then, let's see, still some couple of them coming in. It's time to wrap up here soon. Immersive Time Machine asks, does it mean that Niagara can spawn a skeleton where we can apply an animation so that it will run as a GPU particle?
It means that you could spawn a skeleton component, but it doesn't give those components any new functionality that they didn't already have, such as running on the GPU.
Lucas Rosart asked, is virtual texture streaming compatible with the material layering system?
Yes.
And then last but not least, and I want you all to answer this question, do you like peanut butter?
I love peanut butter.
Of course.
I don't. It's a bit foreign to me coming from France, but I respect it.
And I'm allergic to peanuts, so yes, I love peanut butter, but unfortunately I can't eat it. Cashew butter though, it's good stuff. All right, with that said, we're gonna go ahead and wrap the stream up real quick here. I do wanna mention a couple of things before we leave you all. Make sure that if you're new to Unreal Engine and you're new to game development, make sure you go to unrealengine.com, download the launcher, install one of the latest stable versions of the engine, and check out Unreal Online Learning for courses on how to get started. There are a lot of deep dives there as well, plenty of content to keep you busy for a good time. We also have a whole amazing community that are producing tutorials and videos and how-tos on YouTube. You can go ahead and check out our YouTube channel as well for some of those. We do transcribe all of our live streams, and so if you were watching this and you were unsure about the terminology or the words that we spoke, within a week after the video, the VOD goes up on YouTube, a link to a transcript is posted there with timestamps. And so if you're looking at the stream and you're wondering what we said, you can go ahead and open up the document for the transcript and find out which term you might want to Google for if you want to deep dive a little bit further. Thanks, Courtney, for producing all of those for us every week. Make sure you let us know what you thought of today's stream and all the other streams. We do have a survey. Let's go ahead and paste that right now. I think Sam can jump on that for us. Let us know what you thought and what kind of features and other tutorials you might want us to go through in the future. There are no physical meetups right now, as I'm sure you are aware of, but that doesn't mean that the community groups are not actively organizing virtual meetups as well as other means to be able to get together and spend time talking about Unreal Engine. For all of that, go ahead and make sure you visit communities.unrealengine.com. You can find your local chapter. If there is no local chapter and you are interested in creating one, there's a little button on the right side of the web where you can, on the web page, where you can apply to become a community leader. Make sure you visit our online communities, forums. We have an unofficial Discord channel known as Unreal Slackers. You can go to unrealslackers.org. There are, I think they've reached over 50,000 members now. It's a great place, been there for years. If you're looking for, you want answers to your questions, or you're just curious about talking about Unreal Engine, or, just hang out and lounge and chit chat with fellow devs. Especially good now during the pandemic where, we're not really able to see each other at GDC, there's no PAX, etc. So it's a great place to hang out, good people in there. If you would like to submit content for our countdown videos that we play at the beginning of the stream, go ahead and send a around 30 minutes of development, fast forward that to 5 minutes, and go ahead and send that to community@unrealengine.com together with a logo of your company, you're in the studio, or whatever that may be. If you're streaming on Twitch, make sure you use the Unreal Engine tag, and I would also recommend that you go ahead and add the game development tag. That makes it possible for everyone to find you when you're streaming, and we'd like to come in and check the stuff out that you guys are working on. Make sure you follow us on social media for all news. The same goes for our future live streams. The event section on the forums is where you can find all of the announcements for the upcoming live streams, and that's also where you can go and chime in, potentially ask questions. If something was unclear during the stream and you would like someone to help you chime in and see what that was about, that's the place to go. And make sure that you hit that notification bell on YouTube if you want to see when our new videos are uploaded immediately instead of having to go search for them. Next week, we are going to cover optimizing environment art with Matt Osterley and Jacob Kudel. And so if you're interested in that, make sure you tune in. And big thanks to all of y'all for joining today, taking time out of your day to make sure to show off new features and changes in 4.26. Thanks, Marcus, for preparing a slide deck for us. Very appreciated. Is there anything else y'all would like to leave chat with?
No?
No, get me out of here. I got to get back to making sure this thing ships in a couple of weeks. All right, with that said, I appreciate everyone for coming out and hanging out today. I hope you had a good time. We will see you all next week. And until then, stay safe, everyone.
Yep. All right. Thanks, everybody. See you next time.